Hi, in this video we are going to talk about the single tour implementation of the traveling salesman problem. We have been talking about that at the beginning we have the distinct cities A, B, C up to J. And we would like to connect these cities. Basically, we would like to visit every single city exactly once with shortest path possible. And a single tour is basically just a possible solution. This is a valid solution, so it's going to be the single tour number 1. I said that it is a valid solution because we visit every single city exactly once and we end up with the city from where we have started. So basically it is a closed loop. Okay, we know that it's going to be a so-called Hamiltonian cycle, but what's very important that for the traveling salesman problem, we have to make sure that the given tour is going to be the shortest path possible, which means that the sum of the edge weights are going to be as minimum as possible. So it can be a single tour, that's why it has the name single tour number 1. But it is a valid tour again. It's going to be the single tour number 2. As you can see, the difference is here in the B, F, G, H cities. Okay, so it's going to be the single tour 2. But of course, there may be several single tours. It's going to be another tour, single tour number 3. As you can see, it's just another configuration. So what's very important that we are able to solve this problem several ways. But what's very important that for the traveling salesman problem, we have to make sure that the given Hamiltonian cycle is going to be the shortest path possible. It is a valid solution. It is a valid solution too, but maybe it's going to be the shortest path and not that one. So that's why the single tour is going to contain a private list of cities. So it has the list of city tour. It's equal to a new array list. Okay. And we have a private integer, or sorry, it's a double. Distance is equal to 0 at the beginning. Okay. We are going to define a constructor. If we do not specify any parameter for the constructor, okay, first we have to import a java.util.list. So if we do not specify any argument for this constructor, then we just have to iterate through, so integer I0, I less is than the repository dot, okay, and maybe there's a problem because we have to make it static, sorry for that. Public static city get city and public static integer get number of cities. So after that, we are able to get the number of cities. So get number of cities plus I, we just have to add tour.add a null. We don't want to end up with a null pointer exception. We are going to have another single tour constructor, so single tour, but in this case we get a list of cities as a parameter. So list of city, for example, this is the tour. And here we just have to create a list of city, for example, with the name current tour is equal to a new array list. Then we have to iterate through, so integer I is equal to 0. I is less than this tour.size, so the size of this tour plus I. And we just have to add the current tour, add the null, so we have to initialize this current tour. Then we have to iterate through again, and integer I is equal to 0, I is less than the tour.size plus I. And then we have to set, so the current tour set, and we have to specify the index. The index is equal to I, the element is equal to the tour.get I. Okay, sorry for that, Eclipse sometimes is not being very helpful. Okay, so we create basically a new array list. We initialize it in order to avoid null pointer exceptions, and then we have to set, basically we just have to copy. So the I index is going to be set with the tour get I. And then we just have to set, so this dot tour is equal to the current tour. Okay, so that's all about this constructor. Then we have some getters and setters for the tour. So public list of city get tour, for example. We just have to return this dot tour. Okay, then we will have a helper method, the public void generate individual. This is how we generate an individual tour basically. So for integer I, or it's going to be the city index basically, is equal to 0. The city index is less than the repository dot get number of cities plus plus city index. We just have to call the setCity method with the city index and repository dot get city at the given city index. Of course, we have to implement that given setCity. And what's very important, that after this for loop, we have to shuffle. We have this so-called collections dot shuffle. It's going to randomize basically the tour we have initialized. So basically we are going to create a tour according to the repository, and the repository store a reference to a list of cities. Okay, so we have this setCity, which is basically set, so this dot tour dot set the given index, the city index, with the given city. And what's very, very important, that we have to reinitialize the distance to be 0. Okay, then we have another helper method. I'm not sure whether we are going to use it, but I think that we are going to need it. So city get city at a given tour position. We just have to return with a tour dot get at the given tour position. Then we will have a tour size, so public integer get tour size. It's just going to return the size of the tour. So there are lots of helper methods basically, but I think that it's quite easy to see that the single tour is going to store a single configuration, a single solution basically, and then simulated annealing is going to choose between several single tours according to the energy function, according to the randomly generated number, and so on, as we have seen for maximizing or minimizing functions. So we have this tour size. I'm going to override the toString method. In this toString method, I create a string. It is set to be an empty string at the beginning, and we just have to iterate through the tour basically. I is less than the get tour size, for example, plus plus I, and then we have to append, so s plus equal. It is not the most efficient solution because we should use string builder, whatever. Then we have to get the city, not the class, sorry for that, get the city at the i's positions, and for example some spacing like this is going to be just fine. And then we just have to return with this as string. And the most important function as far as the single tour is concerned is the calculate distance method. So we will have a public, it's going to return with a double, and for example the name is going to be the get distance. So if the distance is equal to 0, then we have to recalculate it. Anyways, we just have to return with the given distance, because sometimes we come to the conclusion that we have already considered the single tour and we have already calculated the distance, so we don't have to bother about anymore. We just have to return the distance if it's not equal to 0. Anyways, we have to define a tour distance is equal to be 0 at the beginning. Basically, we just have to iterate every single city in the tour. So for integer city index is equal to 0, the city index is less than the get tour size, the actual tour size. we just have to get a city. For example, from city is equal to the get city at the given city index position. And we have another city, the destination city. Okay, we don't know what's going to be the destination city, because if the city index plus 1 is less than the get tour size, it means that basically the destination city is going to be the get city with the city index plus 1. But anyways, we know that we have to end up at the same city from where we have started. This is the basic principle for traveling salesman problem. So else we know that the destination city is going to be the get city basically with the 0 index. Okay, and then we just have to sum up the distances. So tour distance plus equal to the from city dot distance to, this is why we have specified this distance to method in the city class. It's going to calculate the distance between the actual city and another city. So where we have been here, okay. So we would like to calculate the distance between the from city and the destination city. And then we just have to set this distance to be equal to the newly calculated tour distance. Just to be consistent, I'm going to return with this dot distance. So what does it mean? We iterate through every single city in the given tour. We get a from city and a destination city. So we iterate through that given tour list that's going to contain every single city. And in every iteration, we get the from city and the destination city, because we would like to calculate the distance between the two cities. And of course we know that if the city index plus 1 is smaller than the get size, it means that, for example, we start here. If the city index plus 1 is not equal to the last index, it means that we are considering these cities. But if we are at the last city, then we know for certain that we have to end up with the city from where we have started, because we have to form a closed cycle. So this is why we have to decide that, okay, if the city index plus 1 is smaller than the tour size, then we just have to consider the next city with the next index. But anyways, it means that we have considered every single city, so we have to get back to the one from where we have started. And of course, we have to sum up the distances. Okay, what's the problem? Oh, because not I, but city index. Sorry for that, of course. So I think that this single tour is going to work fine. In the next video, we are going to implement the simulated annealing. Thanks for watching.